Hello everyone, this is Dr. Dhiman and I welcome you all to this microprocessor tutorial series. So in this video, we will learn about the timing diagram for the opcode fetch operation. So this is for the 8085 microprocessor. So before going to the video, I would like to request you to subscribe my channel and share these videos with your friends so that this channel can expand and it help to grow this channel. So first of all, let us understand what is the timing diagram. Timing diagram actually represents it is the graphical representation of various signals inside the microprocessor or in the microprocessor to perform various operations. It may be a opcode fetch, it may be a memory read, memory write, input output read, input output write. Okay, so there are various types of signals in the microprocessor. Here I have shown this table. This table actually represents various operations and their specific signals that are sent by the microprocessor unit for controlling various operations, as well as the status of the different input output devices, or whether it is a memory access, when it is a memory read, when it is an interrupt acknowledgement, when it is an input output read or memory read or write operation, status signals. This table I have already explained in my previous video. It will help you to understand the various signal values or signal levels at different stages of a machine cycle. So we have already learned that an instruction consists of machine cycle. Machine cycle actually it is only single data transfer. It may be a memory read or memory write, input output read or input output write, or an opcode fetch. Opcode fetch is also a memory read operation itself, okay, but it has some speciality, okay. So it is a little bit different with the memory read, but it is a memory read operation, opcode fetch. So in this video we will learn about the opcode fetch. This row we will implement with the timing diagram. So I will show you with the block diagram how the data is, or how the opcode is fetched from the memory with this block diagram. This diagram has been taken from the microprocessor book by Gankar, okay. So in this video, first let me briefly explain about this table. See, one thing you have to keep in mind, that whenever we have a read operation, that accordingly the read signal will be high or low, okay. So whenever it has a write operation, accordingly we have to make the write enable and we have to make the read disable, okay. So at one instant of time, only one operation can be performed by the microprocessor. For example, here you can see I am explaining you in brief. For the read operation, you can see opcode fetch is also a read, memory read, this is also read, input output read. Okay, OF means this is the opcode fetch, MR means memory read, IOR means input output read. So for this read operation, you can see this is the read bar signal. This read bar signal, this is the active low signal. That means whenever the microprocessor sends a active low signal or zero signal, then the read operation will be performed. Therefore, for this three operation, this one and this one, these are the read operation. Therefore we can see the read signals are 0, 0 and 0. For the other cases it is high. For high, it has no read operation, or it does not perform any read operation. Similarly, now let us see what about the write operation. In the case of write operation, it is also an active low signal. See, in the case of active low signal, when it has a 0 value, that is going to perform the write operation. So for this write operation, see, we have two write operations. This one is the memory write, input output write, okay. So for these two operations, the value are 0 and 0. See, these values are 0. So why these are 0? Because this is the write operation, and write WR bar, this is the active low signal, okay. Similarly, if it is a input output read, then it will be the high signal. See, here you have for these two values. So let me use another color. So for suppose this one value, input output read and input output write, I am showing you here. For these two row, you can see this value is 1. Why these two values are 1? Because input output signal is this is high and memory access is active low. That means whenever this input output / amber signal is high, then it is the input output read, okay. And when input output read or input output write also, it may be, that means it is related to the input output devices or input output interfaces, okay. And whenever we have a memory, then the signal will be low. That means whenever the operation is related to the memory, to the write out the memory or read from the memory, then it will be low. See here in the first three cases, here we have opcode fetch is also a memory read operation. See here all the values are 0. So input output read, input output write, these two. So let me use another color, input output read, input output write. So for these two operations, see this value is high because this is related to the input output. Okay, so similarly INTA is the interrupt acknowledgement signal. Okay, therefore interrupt acknowledgement signal actually given after getting an interrupt signal from the input output devices. Therefore you can see the input output devices, to enable the input output devices or input output acknowledgement is when the processor gets a interrupt signal and the processor stops its operation or it finishes the present concurrent the instruction or concurrent machine cycle, then it hands over the bus or address bus or maybe a data bus also. Okay, so that will be transferred or that will be handed over, the address bus or the data bus will be handed over to the input output or the interrupting devices. Therefore it is related to the input output devices. Therefore this value is 1. All the remaining cases we have already explained. So similarly you can see here that INTA signal is the interrupt acknowledgement signal. This will be a high signal because this is an active low signal. Here you can see it is a bar or complement signal. Therefore for all the opcode fetch or memory read, memory write, input output read, input output write, all the values are high because it is not any type of, it is not sending any type of interrupt signal or it does not require any interrupt acknowledgement. Okay, only for the INTA signal it is going low because it is the interrupt acknowledgement. Therefore to make the interrupt acknowledgement signal, or it is a control signal you can say by sent by the microprocessor, so this will be low only for the interrupt acknowledgement operation. Okay, similarly I have explained this table in details in my previous video. Now let us go to our opcode fetch operation. So opcode fetch means, opcode means it is the operation code. So let me explain. Suppose move b comma a, then this move is the operation and it has some opcode. So suppose let me express, suppose it is 78 H. This H represent the hex code and this is the opcode for this move instruction. I am taking just for an example, this opcode may be different for the move instruction. Okay, so I am just giving an example. B, here will have a comma. Okay, so for this instruction this move is the operation and for this move operation this is the opcode. So this is the opcode fetch operation. So opcode fetch means the microprocessor will fetch the operation code. Opcode means operation code. What is the operation going to be performed? The microprocessor needs to understand. So it will understand by some specific code that is called as the opcode fetch. So in this case, let us understand. So this figure shows the microprocessor unit with the opcode fetch operation. See, whatever be the content of the program counter. So program counter function is that it holds the address of the next instruction to be executed. Suppose the present instruction is now complete. So what will happen? The program counter address will be sent to the memory location. So here we have a memory location. See, this is the memory we have written here. So in this block diagram we can see this is the memory interface and here we have different memory addresses. So here you have these are the memory addresses 2000, 2004, 2005. Okay, this one 2001, 2002, 2003, 2004, 2005. Okay, these are the memory addresses and they are in hex code. So in the case of microprocessor, all the codes are in usually hex code. Okay, hex code means it is the hexadecimal code. So in this opcode fetch operation we have seen that the program counter holds the memory address of the next instruction to be executed. Okay, suppose we have considered various types of instructions. We will see later in this playlist that what are the different types of addressing modes, what are the various types of instruction. We will explain one by one. There are various types of arithmetic operation related instruction, logical instruction also there. So many types of instructions are there. We will see one by one. So in this diagram we are given that the program counter content is 2005. This 2005 is the content of this program counter, or this is the address where the next instruction to be executed, from where the next fetching operation to be done. Because this diagram is for the opcode fetch operation, that means we have to fetch the opcode from the memory. We have to read the memory location 2005. See, this is the memory address and it has 4 digits. So these 4 digits are in hexadecimal code, and the lower digit 05, this will be sent over the address data multiplex bus, and this 20, this higher 8 bits will be transmitted through the address bus A15 to A8. Okay, so through this address bus, this 2005 is coming to the memory unit. This memory unit, this understands the address, and what is the address here? This is the 2005 address. So what is the content here? This is the content. This, let me show you with another color. This is the content of this memory location 2005. 2005, this is a hex code, and this 4F, this is another hex code. 2005 is the memory address and 4F is the content of that 2005 memory address. So this content now need to be fetched to the microprocessor. So this content will come through this path. So here you can see this is the 4F already written here. So this 4F is the content of this memory address. This is the content. This content will come through this path, and this is the data bus. Through this data bus, it will come to the internal data bus of the microprocessor. Okay, so this code will come to the instruction register, and this instruction decoder will decode the code and it will perform the various operations. So this is the basic of the opcode fetch operation. Opcode fetch means we have some address or memory address in the program counter that will go through the address and data bus multiplexed one. That means the higher order bits will be transferred, higher order 8 bits will be transferred to the address bus A15 to A8, and the lower order 8 bits will be transferred to the multiplex address data bus AD0 to AD7. Okay, so here we can see we are sending this through this address bus, this memory address. This memory address will be understood by this memory unit, and it will hand over the content of the memory address through the data bus, and it will come to the microprocessor. This is the opcode fetch operation. We have fetched the opcode 4F from the memory. So this is the operation. Now let us understand what is the timing diagram. So what time which signal is going high or low. So here we have to represent it with the graphical representation, various types of signals. So this is the opcode fetch operation machine cycle. This diagram is taken from the microprocessor book by Gaonkar. So in this diagram we can say we must have the clock cycles. This is the most important. Based on the clock cycles, various signal transitions will be happening. Okay, these are T1, T2, T3 and T4. These are the various T states. T means it is the transition state. Okay, so here we can see opcode fetch operation requires 4 T states or 4 clock cycles. Here you can see for the clock cycle we have to represent various signals. These are the various signals. So first of all, what we have done in this case, that memory, whatever be the content of the program counter, it is put on the address or data bus. Okay, so this is a 16-bit address. 2005 is a 16-bit address. So it will be multiplexed. This 20 will be multiplexed to the A15 to A8. This is the address bus. It will come through the address bus. 05 will come through the address data bus AD7 to AD0. Okay, that means this address bus actually consists of this full bus A0 to A15, but this lower order address bus is also multiplex data bus. Okay, it has dual functionality. It performs based on the time shared. It works on time shared manner. Okay, therefore depending on the time of the execution, it will be working as a address or it will work as a data. So here we can see in this timing diagram, we can see that you can see this is the A15 to A8. It has no multiplexing because this is only used for the address. It will store the higher order address. So we can directly transmit the 28. The higher order address here, this is the 28. This is the higher order address. This is the lower order address. This is the MSB, this is the LSB. So this MSB will be sent through the address bus. See here. So whenever the clock cycle or the machine fetch opcode fetch cycle will start, it will directly load the 20H value in the address bus. But the lower order bits, this 05 is the lower order address or lower order 8 bits. This is the LSB or least significant 8 bits. This will be transferred to the multiplexed address or data bus. So what we have to do, we have to do some functionality so that the address data bus, that is the AD means address as well as data bus, okay, AD7 to AD0, this functions as a address bus for the first clock cycle. So during the first clock cycle, we will use this address data bus as a address bus. So how we will do this? With the signal ALE. See here, whenever ALE signal high, this is the address latch enable. That means whenever we have a high signal at this ALE signal, this multiplex address data bus, that is AD7 to AD0, this will be working as a address bus. You have to understand that whenever we have a ALE signal high, that will represent that this multiplexed address data bus will working as a address bus. Okay, this will be only for the one clock cycle. See here, the lower order address, you can see here, let me use another color, this one 05 is the lower order address of this 2005. See, so this 2005 address with 05 will be loaded to the this address data bus. This one is coming here. Okay, see here, this is the 05H and this will remain in the address data bus for only one clock cycle. During this we can see that 05 is loaded to the lower order memory or lower order bits are lower order memory address is loaded into the AD7 to AD0. So processor sends the address value through the address data multiplex bus as well as the address bus AD15 to AD7. So these are nothing but they are carrying the address for the first clock cycle. Okay, that is the first is the T1. They both are working as a address bus. Okay, now in the second clock cycle, now let us see in the second clock cycle we can clearly see that the address latch enable is 0 here. We have a 0 value here. See, this one was the 1 value, this one is the 0 value. So during the second T state, this address latch enable is low because this is the active high signal. There is no complement here. You can see address latch enable is the active high signal, therefore it is a low. Now when it is low, this address bus, this AD7 to AD0, this multiplex address data bus will be performing as a data bus. It will store or it will contain the data, it will carry the data. Because it is a bus, it will carry the data to the desired point, okay, to the microprocessor. So during this cycle, we can see that the input output, this signal is low for the entire operation. Why this is low for the entire operation? Because you can see that it is the opcode fetch. In the opcode fetch, we can understand that it is the memory read operation with an extra cycle. So this is the opcode fetch operation. That means the microprocessor is going to fetch some opcode from the memory unit. So from memory unit, whenever some data is transferred to the microprocessor, then it is called as the memory read operation. So when we have a memory read operation, we have to enable the memory. So memory part is the active low signal. Therefore, we have to keep this data signal at low position. You see, here we can see input output. This one is the low. Now we have to again understand that this S1 and S0 signal, these are controlling various operations, read or write operation or opcode fetch, or here we can see in this table itself, we can understand that, see this one, in the case of opcode fetch operation, we have 1 and 1. S1 is also 1, S0 is also 1. Therefore, this value S0 and S1 value for this memory address, for this memory access will be always 1. Now let us see the read bar signal. This read bar signal, you can see here, this is read bar signal. This is the active low signal. When there is a memory read, during the memory read operation, the read bar signal should be low because it is a active low signal. See here, when the microprocessor is fetching the opcode for this duration, from here, this point to this point, sorry, this point to this point. So during this period, so let me show you again here, from this point to this point, the microprocessor read bar signal is low. That means the microprocessor will do the or will function the read operation. So for this read operation, see the data, it is now reading. See, data is being read. This is the data available in the memory address. See, this was the 4F was the data. Okay, this data is now in the data bus. So this 4f is the data. So let me wrap this part, that here one question may arise in your mind, that why these are two lines in the case of this for the address bus and the data bus. See, here we have two lines, here also we have two lines, all the remaining lines are only single line. In the case of sometimes if we draw the S0 and S1 line, then we will have the two line. Okay, why these are showing the crossover and like that? Because you can see here A15 to A8, we have here 8-bit address bus. See, the address bus and the data bus are shown by two parallel lines. This is commonly actually used practice to represent the logic levels of different groups of lines. Why group of lines? Here we can see A15, A14, A13, A12, A11, A10, A9, A8. We have 8 bits of data. See, it is not only a single line, it is a group of line. 8-bit is transmitted parallelly. Therefore, we have to represent with some way to represent it is a 8-bit data or 8-bit parallel lines. This is a commonly used practice to represent the logic levels for group of lines. Okay, some lines are high and others are low depending on the information transmitted. Okay, because it is 8-bit address, it will represent various types of information. 2-bit hex code it will represent, and this hex code will change for different operations, and some of them, the bit lines, will be high or low depending on the data. Okay, the crossover of the lines, crossover means this point. So let me use another color. Crossover means this point, these points, these are the crossover. Okay, so this crossover of the lines indicates that the new byte or information is placed in the bus. Okay, whenever there is a change in the information, then it will be crossover. There will be a crossover. Here you can see the address bus is containing the higher order address for 3 clock cycles. It is function like that, it's operation like that. This address bus A15 to A8 holds the data for 3 clock cycles, and for the remaining 4 T4 it is unspecified. Okay, so we have understood why there is a two parallel lines in the case of address and the data lines, because we have multiple bits transmitted parallelly. Some bits may be low, some bits may be high. Okay, we are representing by two parallel lines. Okay, now the crossover lines indicates that new byte is informed, or new byte or information is placed on the bus, and the dashed straight line indicates the high impedance. Here we have already seen that these are the dashed line. These are the high impedance states. There is ambiguity in the information, or we cannot directly predict whatever be the content of that content during the cycle. So while drawing this timing diagram, you have to keep in mind that when the signals are going high, when the signals are going low, you have to keep in mind the timing is the most important part in the case of timing diagram. Suppose in the question, if in the examination you are drawing this timing diagram, every part is okay, but you are suppose making the address latch enable here like this. So during this period also, this address data multiplex bus is going to be working as a address bus. See, whenever AL is high, this multiplex data or address bus will be working as a address bus. So there will be no opcode fetch. Therefore, your timing diagram, whole timing diagram will be getting wrong. So you have to know the timing when the signal is transiting or when the signal is going up or down. Okay, so in this way you have to understand the various operations through the timing diagram. Okay, so this is for the 8085 microprocessor fetch operation. This is the opcode fetch operation. Opcode fetch means operation code is read from the memory. Basically it is a read operation, but during this read operation we have an extra clock cycle, T4 clock cycle. Okay, so that we have to understand. Okay, so after getting the opcode is decoded in the T4 cycle. This T4 cycle, why we require extra? Because this is for the opcode decode, because the microprocessor has to decode the opcode also, and the microprocessor examines the ready signal in T2. Okay, so whenever during this T2 cycle the microprocessor finds whether it is ready or not to perform the operation. When it is high, the microprocessor enters into T3. If it is low, the microprocessor inserts a wait state between the T2 and T3. See here, T2 and T3, if it is high, T2 is, if it is high, then it go to T3. When it is low, it will remain, it will wait. There is a wait cycle. I have already explained in my previous videos. So watch all the previous videos also, and all the upcoming videos also you have to see, then only you will understand. So I have explained with the block diagram and the timing diagram. So in this way you have to understand that for drawing the timing diagram you have to remember some functionality shown by this table. You need not to actually remember this table, but you have to remember the signal operation. That means whenever we have a read bar signal low, then it is a read operation. Whenever read bar signal is high, then it is not a read operation. Okay, whenever the write bar signal is low, then it is a write operation. Whenever we have a write bar signal is equal to low, then it is a write operation. Whenever it is high, then it is it may be a read operation or it may be something else, but it is not a write operation when it is high. Okay, similarly for the input output, and this S1 and S0, this actually indicates the various types of operation, whether it is opcode fetch or memory read, memory write, input output read, input output write, depending on the various combinations of the S1 and S0, because these are the status signals sent by the microprocessor. So depending on these signals, we will perform various different types of operation. We have discussed the opcode fetch machine cycle during this video. I hope you are benefited from this video. Thank you for watching. If you have any question, please put it in the comment section below. Also like, share and subscribe to my channel. Thank you.